question says, consider the graph below. Which of the following gases has the highest molar mass? So since we're looking at highest or lowest, all right, in this case highest, I'm going to consider the two extremes. I'm going to skip C and B, all right, B and C, because they're not at the extreme, so they're probably not going to be the highest or the lowest. So let's look at what we have on the axes of the graph. So here we have molecular speed, I'm going to call it in meters per second, and here we have the relative number of particles, or the distribution. So if we look here, let's assume that this is a perfectly symmetrical curve. Probably isn't, but let's just assume that it is. If it's a perfectly symmetrical curve, then the average, okay, speed is right here, which for A is around 1100 meters per second. Not exactly, but close enough. And if we look at D, the average speed is right here, okay? And if we look at that, we'll call that, say, it's around 300 meters per second. These aren't meant to be perfect. So let's look at this. Molecules A are moving much faster than molecules D. Now let's assume that the total number of molecules, or the total area under the curve, for this one and this one are exactly the same. So there's the same number of moles of A and D in the sample. That means that at the same temperature, A and D are exerting the same amount of force on the walls of the container. Said another way, they're exerting the same exact pressure. How is it possible for two molecules moving very, very different speeds to be exerting the same amount of pressure on the walls of the container? It's because of the mass. D molecules are much, much more massive, so they have to be moving slower. A molecules are much lighter, so to exert the same amount of force, they have to be moving much faster. If you think about a crash test, okay, with a compact car and a Mack truck, all right, crashing into a wall. If they want to exert the same amount of force, so say you have the Mack truck at 20 miles an hour, it hits the wall, it exerts a certain amount of force. How do you get the compact car to exert the same amount of force? Well, you have to make the compact car go much, much, much faster because it has a much lower mass. And this might be a bad example because it might not be possible. But assuming that it's possible, the way to do it is to move the compact car much, much, much faster. It's the exact same thing here. A molecules are much smaller, so to exert the same amount of force, they're moving much faster on average. And D molecules are much larger, so therefore they're moving much slower. So the answer to this question is D. But before we leave, there's one other thing I want to point out. You'll also notice the distributions are much different. The A molecules have a range of speeds from 0 to, say, 2300. The D molecules are from 0 to, let's say, 1100 or 1150, something like that. So you'll also notice the A molecules not only are moving much faster on average, but they have a much greater range of speeds. And that's something that can come up.